Coordinate Plane and Order Pairs Part 2. Lesson Objective: Identify important parts of a line. We'll begin with this example. Find 5 order pairs to the equation y equals 1/2 x minus 3 and then sketch the graph. So we're given a table of values. X have been picked for us, -2, -1, 0, 1, and 2. To get the corresponding y values, we substitute the given x in the equation and we follow the order of operation to get y. So for -2 we have y equals 1/2 times -2 minus 3. 1/2 times -2 is -1. -1 minus 3 is a -4. So our order pair is -2, comma, -4. To plot that on the graph, we go to -2 on the x-axis and then we go -4 on the y-axis, and this will be our location for that point. For -1, we have y equals 1/2 times -1 minus 3. We multiply first. 1/2 times -1 is a -1/2. -1/2 minus 3 is -3.5, or -3.5. Plot the order pair -1, comma, -3.5. We go to the x-axis first, then the y, and our point will be somewhere around here. For 0, we have y equals 1/2 times 0, which is 0, minus 3 becomes -3, which is this location. This is known as the y-intercept. We'll talk more about that in a little bit. For x equals 1, we have 1/2 times 1, which is a half, minus 3 is -2.5. We put that on the graph and the point is here. And lastly, when x is 2, y becomes -2. Putting this on the graph, we have our 5 points. And again, y equals 1/2 x minus 3 is a linear equation. The graph will be a straight line, and if we draw our line, we can see all those points are on that line. Now in statistics, when we do scatter plots, many times there will not be points exactly on the line, and that's okay. That's why we call it a scatter plot. The points can scatter away from the line, and that's okay. But as long as there's a linear relationship between the two variables, we can use one to predict another, and the line will help us with that prediction. Let's do another example. This time the equation is y equals 0.25 x minus 3.5. Now as you start working with real data, most of the time your values, your coefficients and your constants, like this 0.25 and 3.5, they are going to involve decimals. This makes it harder to graph by hand, but that is okay. In statistics, we are going to let StatCrunch plot the scatter plot and figure out these constants and coefficients. But for this example, we are going to just use the order of operation, get the values, and plot them by hand. Okay, for x equals -2, we have 0.25 times -2. Using your calculator, if you plug these values in your calculator, you should get -4. 0.25 times -2 is a -0.5, and -0.5 minus 3.5 is a -4. And again, it's good to have a basic calculator out here and let the calculator do the computations. To plot the point, we go to -2 and then we go to -4 on the y, and we get this point here. Next would be -1. 0.25 times -1 minus 3.5 becomes -3.75. Now that's going to be hard to graph exactly, but we just sort of estimate the best we can. So plotting that point, it will be somewhere around here. When we do 0, we are going to get -3.5. 0 times any number 0, so that's going to be 0 minus 3.5, which is a -3.5, which is here. That is our y-intercept. That is where this line is crossing the y-axis. Now you may ask yourself, will that always occur when x is 0? And the answer is yes. When x is 1, we have an output of -3.25. Again, we sort of estimate it. It's about right here. And lastly, when x is 2, y is going to be a -3. Again, we have a straight line. We put our line in, it's going to look something like this. It does turn out to be what we call a positive slope, but this positive slope is not as steep as the other example. Intercepts of a line. For this example, we have two intercepts, a y-intercept, and that is where this line is crossing the y-axis, and that's called the y-intercept. It will always have a value of x equal to 0. This is the point that is crossing the x-axis, and it's always going to have y equal to 0. In statistics, the y-intercept is important because that is like our initial or starting value. And the initial value means, okay, if x, our explanatory variable, is equal to 0, what is the predicted value of y? And that is really why the y-intercept is important in statistics. So the thing to keep in mind is a y-intercept is a point. It is when x is equal to 0. Let's look at this example. Here we can clearly see that this is where the line is intersecting the x-axis. So our y-intercept is 4. To label it as a point, we would say 0, 4. For the x-intercept, that would be 5, and if we write that as an ordered pair, that would be 5, 0. Let's do another example. For this example, the y-intercept in this case is a +2, and the x-intercept is a -7. So again, intercepts are just points. Let's talk about slope. The slope of the line is the pitch. So as I go from here to here, how are the x values and the y values changing? Well, in this case, as we go left to right like reading a book, this tends to be decreasing. As x gets bigger, y is getting smaller. That is slope. So slope explains how much the x and y values are changing. It's also known as the rate of change. Geometrically, we can express slope as rise over run. Rise is the change in y, because if you rise, you're going to go up or down. That's the change in y. And if you run, that is left to right, and that is the change in the x values. Rise over run, in this case, if we look at this point to this point, we are going down, so this would be negative because this value is bigger than this y value. And then the run, we're going from here to this point here. This is our run. That would be positive because we're going in the positive direction. Think of a number line. If you go to the right, it's positive. This is what we call a negative slope. Let's do another example. So here we can see the y-intercept is 4, the x-intercept is 5, and again, this is going to have a negative slope. So how do we compute what the slope is? Well, how are we changing from this point to this point? Well, the change in y, or the rise, would be negative. We're dropping from 4 to 0, so that is -4. We're going down, it's negative. We go up, it's positive. And then the change in x, we're going from 0 to 5. That's an increase of 5. So the slope would be a -4 over 5. It's a negative slope. Now, we don't have to compute this by hand or count. Once we start using data, StatCrunch is going to compute the slope for us. We just have to be able to interpret this slope. Now, if we were to take -4 and divide it by 5, we would get a -0.8. In that case, as x goes up by 1, y goes down by 0.8. We'll talk more about this later. Let's do another example. So for this one, if we start at this point, this x-intercept, and we go to this point, how are the x and y changing? Well, the rise would be a positive 2. We're going from this point to this point on the y, so that's an increase of 2. The rise is a positive 2, and then the run is going to be from here to here, which is a positive 7. We count 1, 2, 3, 4, 5, 6, 7. So this slope would be 2 over 7. For statistics, we are interested in the y-intercept and we are interested in the slope. And if we have those two pieces of information, we can have an equation of a line. So if you recall, y equals mx plus b, the b turns out to be the y-intercept and the m turns out to be the slope. And we'll talk more about that in a future video. Let's do an example of a real-life situation involving a linear equation. A salesperson receives a base salary of $35,000 and a commission of 10% of that total sales of the year. A. Complete a table of values and use the results to list order pairs that satisfy the equation. B. Graph the linear equation using the points obtained in Part A. So for this example, we have two variables. One variable is the amount that the salesperson is going to make, the salary, and the other variable is the total sales for the year. So which is the independent and which is the dependent variable? Well, if we think about it, the salesperson's salary depends upon the total sales for that year. So the independent variable would be the total sales for that year. The dependent, or the response, or the output, would be the salesperson's salary. Now we are given that the base salary is $35,000. That means if the salesperson doesn't sell anything for a year, he or she will still get a base salary of $35,000. So that's like your initial value. This turns out to be the same thing as the y-intercept. We'll see that when we graph it. That is going to be our slope. That is what's changing. As x increases, this number is going to increase. Therefore, the total for the equation is going to increase. That is our slope. We've already talked about if the sales is 0, this person is still going to get a base salary of $35,000. Now, if they sell $100,000, again, this is the independent variable. This was already given to us. We would take the 100,000, plug it in for x. So we're taking 10% of $100,000, which is $10,000, and then add it to our base. And we get a total salary of $45,000. If x gets bigger, in this case 200,000, we substitute 200,000 in, multiply it by 0.10, and we would get 20,000. 20,000 plus our 35,000 becomes 55,000. So the y-intercept is the initial starting value of 35,000, and as x gets bigger, y is going to get bigger. And by how much? Well, that turns out to be 10%. To put this on a graph, these numbers are quite large, so I'm going to scale the axis for both. For the x-axis, I'm going to scale it 100,000, and for the y, I'm going to scale it 10,000. So plotting our points, when x is 0, y turned out to be 35,000. So in this case, this would be 3.5. When x was 100,000, or 1 for our graph, y was 45,000. And when x was 200,000, or 2 for our graph here, we had a value of 55,000. So we can see this is our y-intercept, and our slope turns out to be 10% of the total sales. Thanks for watching.